All right, so we're going to wrap up this unit on the Renaissance and the Reformation with a short section here on the scientific revolution. Now, I don't want you to think that the scientific revolution is just an add-on tacked to the end of this unit, because it really is, if you think about it, a continuation of something we talked about on the first day of this unit, that idea of humanism. Using the ideas and human reason and logic, as the Greeks and Romans had done, to better understand the world around you. So this is just as the Renaissance and the Reformation in Northern Europe was an exploration of the religious aspects of humanism, so too the scientific revolution is an extension as well, trying to understand the world around them, questioning things, not taking them by blind faith. Our objectives in this section: explain how new discoveries in astronomy changed the way people viewed the universe, quite literally. Understand the new scientific method and how it developed. We'll look at the contributions that Newton and other scientists made to the scientific revolution. Our focus question: how did discoveries in science lead to a new way of thinking for Europeans? Now, the mid-1500s present a tremendous shift in thinking that finally shows a break from the Middle Ages, the medieval past. And at the center of the scientific revolution is this assumption that there are natural laws, mathematical laws, that govern nature and the universe. What that means, and this is the great discovery of this period, is that people can know, manage, understand, and shape the physical world. So let's start here at the heart of it all. Until the mid-1500s, Europeans had believed what had been accepted 1,000 years before the Renaissance, the teachings of Ptolemy and Aristotle, that the Earth was in fact the center of the universe and all the other heavenly bodies revolved around the Earth. Over time, this had also become Christian church doctrine. And as Christian church doctrine, this is what people were expected to believe. In 1543, along came the Polish astronomer Nicholas Copernicus, who presented a significant challenge to this view that the bodies rotate around the Earth. He presented a model that was heliocentric, or a sun-centered model. The Earth was, like other planets, all revolving around the sun. Now, it's interesting to note that Copernicus published his work just before his death. He'd actually made this discovery several years before, but he didn't want to release it. He didn't want necessarily to have that information out there because of the threat that challenging church doctrine might have. So just before he died, his work was published. Now, for most, Copernicus's revolutionary theory was rejected. The fear was, and I think this was basically because of fear, the idea was, as if we're going to question the work of the classic scholars, then, oh my gosh, all of the knowledge that we know, all of our known world, might also be called into question. This was, it may be difficult to understand, but this was quite a challenge to their life at the time. But others continued to work along the lines of what Copernicus had proposed. In the late 1500s, the Danish astronomer Tycho Brahe made observations of the heavenly bodies and supported Copernicus' theory. After Brahe's death, his assistant, Johann Kepler, used that data that Brahe had collected to calculate the orbits of the planets around the sun. So more detail, increasing information coming in at this point. And Kepler took it one step further. He found out through his observations that the planets didn't move in perfect circles in their orbit. that it was more elliptical in shape. Scientists in several different countries continued to build upon the work of Copernicus and Brea and Kepler. In Italy, Galileo Galilei built a telescope, and he observed the moons of Jupiter and how they orbited around that planet. He made the extension from that observation that the movements of those moons around Jupiter is the same as the orbit of the planets around our own sun. Now, as we talked about before, this understanding or this statement based on observation contradicts church doctrine that the earth was the center of the universe. And this definitely got Galileo Galilei in significant trouble. In 1633, Galileo Galilei is brought before the Inquisition. So again, this is the same Inquisition we've talked about that began in Spain, was used against the Protestants, and this is also a court before which Galileo Galilei is brought, and he's forced to recant his theory that the earth is not the center of the universe. So Galileo Galilei did recant his quote-unquote heresy, but the story goes that as he left the court, he said, "And yet it moves," meaning that the earth moves and is not the center of the universe. So he probably did it out of pressure, and certainly not because it's what he believed. So despite pushback from the church, there's a new approach in science in the early 1600s. People are getting more and more courageous in pushing what had been established church doctrine. Scientists went back and rediscovered the work of Plato, and they started to understand that mathematics and the rules of mathematics are key to understanding and learning more about the universe and how it functions. Two philosophical giants coming out of the scientific revolution, Francis Bacon and René Descartes. Both of these gentlemen, as philosophers, challenged the idea of the scholarship in the medieval age that tried to make everything that they understood about the world fit within the established teachings of the church. So without rocking the boat, without pushing the envelope, so to speak, Francis Bacon and René Descartes really were the ones that tried to push any scholarship, any academic and study out of this mindset. For both of these philosophers, Bacon and Descartes, they argued that at the beginning of an inquiry, at the beginning of a study, you're not going to know what is truth. You're not going to know that until the end of the process. This is significant, as we'll see as we go forward here. So Francis Bacon stressed that in order to get to the truth, you have to observe things, you have to experiment and see what happens when certain things are put together or when certain steps are taken. Bacon also wanted to stress that he wanted science and any discoveries coming out of science to be useful in people's lives, something practical that will better the lives of people. Descartes may be a little more elusive, and I am certainly not a philosophy expert, but Descartes emphasizes that human reasoning or logic is the best road to understanding. His famous publication, Discourse on Method, he throws out traditional authorities to search for knowledge that he could prove. He goes so far as to say the only thing he couldn't question was doubt. So you need to ask questions, you need to challenge the status quo in order to come to a decision or come to some kind of understanding as to what truth is. Now, certainly as you get into college and you study philosophy, you'll learn more about Descartes, and I've certainly simplified it as much as I can at this point. But you get the gist of it. Over time, as we move into the 1600s, we have a new method, the scientific method, that's developed, again, embodying these ideas of observation and testing, experimentation. So it requires the collection of accurate data and the proposal of a a thesis or a hypothesis that is tested throughout the process. And you should be very familiar with this from the science classes that you've taken already. So basically in step 1, you're going to state the problem, you're going to collect information regarding the problem, you're going to come up with a preliminary thesis or an educated guess as to how things are. You're going to test that hypothesis, collecting data, analyzing data along the way, draw some conclusions as to whether that hypothesis is accurate, communicate and share the data, answer any questions, and then refine that process in a circular method. Medicine also saw some dramatic changes and advancements in the 1500s and the 1600s. Andreas Vesalius published his famous work on the structure of the human body in 1543, which was truly the first all-encompassing, detailed study of the human anatomy. Now, we certainly talked about Michelangelo and his drawings, but this is one that is more focused on anatomy in its entirety. So Vesalius. Anton van Leeuwenhoek perfected the first microscope. Here's an example of what that looked like. I can't quite figure out how this works, but he was able to see at a very microscopic level, to see things smaller than the human eye could see naturally. It opened up an entirely new world for study. William Harvey described how blood is circulated throughout the body and actually showed that the heart is a pump circulating blood both into and out of the heart, out to the extremities, and adding oxygen to it as it goes. So William Harvey, circulation of the blood. The Frenchman, Ambroise Paré, developing new surgical techniques and tools, but also, as you'll see here, some examples of artificial limbs, in addition to ointments that prevent infection. So Paré improved upon a lot of things and brought a lot to the advancement of medicine during this time frame. Chemistry was also transformed during the scientific revolution. In the Middle Ages, chemists or alchemists, as they were called, the main goal was to try to transform whatever they could find, ordinary metals, into gold. The main guy in the advancement of chemistry in this time is Robert Boyle. He explains that all matter that we have on the earth is composed of tiny particles that behave in ways that we can understand, in ways that we can know and predict. Boyle also helped define the difference between individual elements, so think about your periodic table, and compound elements, obviously very significant in the understanding of chemistry. He also explained the impact of temperature and pressure on gases. So Boyle and his accomplishments in the advancement of chemistry. I'm sure you've heard of Isaac Newton before. He linked together the study of science with mathematics. He is a giant in this field. He theorizes that gravity is the force that controls not just apples falling from trees, but the movement of planets in space. So gravity. He also believes that all the motion that happens in the universe can be measured and described in mathematical terms. Again, this discovery that there are mathematical rules that govern nature and natural law, and that we can understand and know these things by using mathematics. Also made significant contributions to calculus, certainly a branch of mathematics that some of you know and will explore in your future academic careers. So some of the key terms in this section: Nicholas Copernicus, the first one to propose a heliocentric model of the universe, that the Earth actually revolves around the sun and is not itself the center of the universe. So heliocentric, his idea that the sun, not the Earth, is the center of the universe. His work extended by Tycho Brahe, Brahe's assistant, Johann Kepler, actually plotted the orbits of the planets and discovered that they're not in fact round necessarily, but that it's more of an oval or elliptical shape. And then down in Italy, Galileo Galilei proposed also that the Earth revolves around the sun. He was hauled in before the Inquisition court and forced to recant his heliocentric views. Now, obviously, since this time in 1633, the Church has accepted the position that the Earth is part of a heliocentric model and that the sun is not, or the Earth is not, the center of the universe. Philosopher Francis Bacon. Philosopher René Descartes, searching for provable knowledge. Scientific method, step-by-step process to collect data, propose a hypothesis, and over time measure and prove and tweak that hypothesis. Hypothesis, a possible explanation for a problem to be tested using scientific method. In chemistry, Robert Boyle, all matter is being composed of tiny particles that behave in knowable ways. Isaac Newton, gravity, contributions to calculus. So this brings to a conclusion our unit on the Renaissance, the Reformation, and the scientific revolution. So think about at the higher 10,000 foot level how these three areas are linked together. The idea of humanism, the idea of using reason to observe the world around you, and how that led to a broadening of people's awareness, a broadening of their thirst for knowledge, and significant advancements, both in religion, established religion, but also in science, chemistry, math, and the like.